In this video, we will solve a question on the relationship between cross price elasticity of demand, income elasticity of demand, and own price elasticity of demand. Okay, so this question, the stuff you will not find it on the YouTube. I guess it is my privilege to be the first person to solve this kind of interesting question. The question is, assume that a consumption basket of a utility maximizing consumer consists of only two goods. Okay, so consumer consumes two goods X and Y. We are also being told that the own price elasticity of demand for good X is minus 1.5 and the income elasticity of demand for good X is 5 here. We have to find out the cross price elasticity of demand for good Y. That is, how will the quantity demanded of good X change due to the change in the price of good Y. Okay, so what we are being given here, income elasticity of demand is also being given. Own price elasticity we have to calculate. Okay, sorry, own price elasticity is given and we need to find out the cross price elasticity of demand. Let's write a general demand function and let's write it. Let us say X, that is demand for good X, is a function of here the price of good X, that will denote the own price elasticity of demand, price of good Y, and this will give us then the cross price elasticity of demand, and income, and it will give us the income elasticity of demand. We are saying that demand for good X is a function of prices and income. When we have this kind of demand function, we call this the Marshallian demand function. Marshallian demand function. Demand function. And one of the property of Marshallian demand function is that one of the property of a Marshallian demand function is that it is homogeneous. Homogeneous of degree 0 in prices, that is price of good X, price of good Y, and income. A Marshallian demand function is homogeneous of degree 0 in prices and income. By homogeneity, we will explore all the things here, what is meant by homogeneous function. Okay, so this will be an interesting question to be dealt with. So let's first understand what is meant by homogeneous function. We say, let us say, a function f of xy, that is, we say this function is homogeneous of degree, let us say, n, if we increase both variables, that is x by lambda, and we also increase y by lambda. That means if we increase both the factors or variables by the same factor, and if we get the resulting function like this, that is lambda raised power n times the original function, we say this very function is homogeneous of degree n. Okay, if somehow we are able to factor out lambda from this entire function, we say it is homogeneous of degree what we call n here. So for example, if we have a function, let us say f of xy is equal to x plus y, if we increase both x and y by a factor lambda, that is lambda x comma lambda y, so we will get here, so in place of x we have lambda x and in place of y we have lambda y here. So we take lambda common, we are left with x plus y, and here you can see x plus y is our ordinal function, that is lambda times f of x y. So this function is homogeneous of degree 1. That is, if we increase both x and y by a factor lambda, the given function will increase by a factor lambda. And similarly, let us say we have another function f of x. So this function is homogeneous of degree 1, and let us take another function f of xy is equal to x divided by y. Increase both x and y by a factor lambda, that is f of lambda x comma lambda y will be equal to lambda x divided by lambda y. Lambda gets cancelled, so we will get x upon y. So in place of lambda I can write lambda raised power 0. So when we increase both x and y by a factor lambda, so here we will get lambda raised power f of xy. So this function is homogeneous of degree 0. Okay, so this is how do we find out the homogeneous. And this Marshall and demand function is actually homogeneous of degree 0 in price and income. By this what we mean, and we will explain it here. It simply tells us if we multiply all prices and income by the same amount, demand does not change at all. Okay, so let's go first into the question, then I will explain more about the Marshall and demand function. So I can write, and we have to apply here the Euler's theorem. That is, so using Euler's theorem, Euler's theorem states that if, or let me write it here, for a homogeneous function, let us say, if we have a homogeneous function, what happens? If we take the partial derivative, that is the change in x given this homogeneous function, the change in x due to the change in the price of x times price of x plus the change in the demand of good x due to the change in the price of good y times price of good y plus the change in the demand for good x due to the change in the income times income will be equal to n times x. Okay, so homogeneous function, for a homogeneous function, if we take the marginal products and multiply it with the prices and income, we will get n times the given demand function. Okay, so for since this is the whole, what we call, and here we know that n is equal to 0, because the given Marshallian demand function is homogeneous of degree 0, then what will happen? That means the change in the x due to the change in the price of x times price of x plus the change in the quantity of good x times the change in price of y times price of y will be, or rather, then we have plus the change in the quantity demanded of x due to the change in the income times income will be equal to, so since we have this function which is homogeneous of degree 0 in prices and income, that means in place of n we have 0, we will get 0 times x. So 0 times x is in fact equal to 0. So let us cut it short here. So we write it here 0. After that, what will we do? I got the required color. Then what will we do here? Let's write the given demand function again. This very stuff, that is the change in x upon the price of x times price of x plus dx upon dpy times py plus dx upon dm times m is equal to 0. What will we do then? Let's divide both sides by x. Okay, dividing both sides by x. So here we have x, here we have x, here we have x, and 0 divided by x is in fact equal to 0. Now here you can see this very stuff. What is this? This shows the change in the quantity of good x due to the change in the price of good x times price of x upon quantity of good x. So this seems familiar to us. This is actually the own price elasticity of demand. Okay, by own price elasticity, what we mean, it shows us the responsiveness of quantity demanded of good x due to the price change. Okay, so this is our in fact this is our price elasticity of demand. Plus, and what about this this term? So the change in the demand for good x due to the change in the price of good y, that's another good, times the price of that very another good, that is price of y divided by x. And this is in fact the cross price elasticity of demand, and let's denote it by E subscript C. Okay, I don't know the subscription here, so let's write it here C. plus, and what about this this very stuff? It shows the change in the demand of good X due to the change in income times income upon the demand of good X. It shows us the income elasticity of demand. Let's denote it by E subscript M, and it is equal to 0. And it simply tells us if we take the partial derivative of the Marshallian demand function, and obviously multiplying then with the price of X, price of Y, and price of M correspondingly, then the then all the elasticities will be equal to 0. Okay, so we can also say the homogeneity condition in this question states that the sum of own and cross price elasticities and income elasticities for a particular good is equal to 0. Given the given function is Marshallian demand function, we are talking about the ordinary demand function and not about the Hicksian demand function. Okay, to be very precise here. Now, what does actually, so what we are being given, we are being told that own price elasticity of demand for good X is minus 1.5. So here we have minus 1.5 plus cross price elasticity we need to find out, and income elasticity is being given us as 5, and it should be equal to 0. Okay, so it implies, let's write it here, E subscript C plus 5 वालों dot near 3.5 is equal to 0, or E subscript C transposing this here, it will become minus 3.5. That means the cross price elasticity of demand will be equal to minus 3.5. So when we say we have this Marshallian demand function, okay, and by Marshallian demand function what we mean, a function when the quantity demanded of a good depends upon the prices and income, we say it's a Marshallian demand function, and it is one property, important property is that it is homogeneous of degree 0 in prices and income. That is, if we multiply all the prices and income by same amount, demand does not change at all. Okay, so it makes sense. Imagine the government doubles all the prices and also doubles our income. There is no reason for us, to change our demand, as nothing really got cheaper. Why? Because, let us suppose price of good X was $10, income was, let us say, $100, and we were demanding 10 units of good X. अचानक से क्या हुआ? Price of good Y was doubled to 20, income was also doubled to 200, and what happened to the demand? So demand will be equal to 200 divided by 20. That means demand will remain same, that is equal to 10. That means doubling income and price will have no effect on us. Okay, let me repeat it here. If government doubles all the prices and also doubles our income, there is no reason for us to change our demand, as nothing really got cheaper here, nor did our income increase it in real terms. Okay, so this is how do we find out the relationship between the cross price elasticity of demand, income elasticity of demand, and own price elasticity of demand using Euler's function. Euler's function states that if we have a homogeneous function and if we take the partial derivatives of that very function, okay, and multiply obviously with, here in this specific case, with the price of X, price of Y, and income, then it will be equal to n times X, and n denotes the degree of homogeneity since n is equal to 0, so we will get this very result. I hope I make myself clear in this video. Thank you.